So as you can see from here, this is our time of flight. Now to calculate the range, what we'll do is we'll simply multiply the time of flight with the velocity component in x direction, which is u cos theta. So the range r would be velocity component in x direction, which is u cos theta, into time of flight, so u cos theta into u sin theta plus u square sin square theta plus 2gh by g. So this is the value of the range of projectile. Now let's discuss the case when a projectile is thrown on an inclined plane, which is inclined at an angle alpha with the horizontal, and the projectile is thrown at an angle beta with the plane. So first let's see this animation. So here we can see that suppose this point is O. So OX is our inclined plane and OX is inclined at an angle alpha with the horizontal, and the projectile is thrown with the velocity u, which is velocity of projection, and the angle of projection is beta. And this is the angle which projectile velocity makes with the inclined plane. So to solve this projectile motion, to get various parameters of this projectile motion, that is the range, the maximum height, and etc., what we'll do is we'll consider our coordinate axis to be along and perpendicular to the inclined plane. So instead of taking our usual x and y axis, we'll take the x axis along the inclined plane, that is OX is our new x axis, and the y axis is perpendicular to it, so OY is our new y axis. Now we'll try to resolve our velocity component and acceleration component along x and y direction. So ux, which is the component of velocity along x direction, and the x direction is now along the plane, so this will be u cos beta ux, and uy would be velocity component perpendicular to the plane, u sin beta. Similarly, we have acceleration g. This will also have two components. The component along x direction, that is along the plane, would be ax is equal to g sin alpha. Now note that the direction of g sin alpha is in the opposite to the initial velocity. So if we are taking this direction, that is direction to the right of OY as positive, the direction of AX would be negative, so AX would be minus g sin alpha. Similarly, AY would be minus g cos alpha, because direction above the plane OX is taken as positive and the direction of g cos alpha is below that plane, so AY is negative. So now we have the velocity and acceleration along x and y direction. Again note that x direction is along the plane and y direction is perpendicular to the plane.